Specialist Mathematics, Paper 1, Tech Free 2023. Now we're looking at question 18. Now it's a differential equation. Particular solution to this differential equation where x is bigger than or equal to 0 and y is between negative pi and 2 and 0 passes through the origin. Determine the solution in the form x equals a function of y. Leave your answer in simplified form. So let's make a start. dy dx, x over x squared plus 1 tan y. Let's bring the tan y over here with the dy, x over x squared plus 1 dx. Integrate both sides. Now we go to our rule sheet and we go tan, integrate. It's not there. We cannot integrate tan straight up. But what we do know is we know tan is sine y on cos y. So we'll get to that one in a minute. This one is, if I make it a half, 2x over x squared plus 1 dx, that's the integral over the bottom. Because that's a great rule, because it's logs. Is that what we can do here? Now, the differential of cos is minus sine. So I want a minus sign there, so I'm just going to put a minus at the front. So this will be negative ln cos y equals a half ln x squared plus 1 plus c. It's still not looking very simplified, but we have integrated. So getting here, doing this and then getting this point, you got 2 marks. Now, very important, it says that it passes through the origin. So x equals 0, y equals 0. Okay? That's what we can use to find c. So negative ln cos 0 equals a half ln 0 squared plus 1 plus c. Negative ln, now the cos of 0 is 1. ln 1 plus c. Hopefully from your methods you remember ln of 1 is 0. 0, 0. Therefore c is 0. So negative ln cos y equals a half ln x squared plus 1. So c was in fact 0. Now there's a couple of options of how you wish to proceed from here. We are definitely going to use the fact that we have these numbers at the front, these coefficients are going to become powers. And there's a few options you can go with. I'm going to bring the half over here, so it becomes negative 2 ln cos y equals ln x squared plus 1. One way to go. So that's ln cos y to the negative 2. Now that's going to be ln sec squared y equals ln x squared plus 1. Simplified. Now we have ln of that equals ln of that. Sec squared y equals x squared plus 1. Sorry, that's a pen mark. And we're like, okay. Ooh. Now we want it in the form of x equals a function of y. So if I make it as x squared equals sec squared y minus 1. Can I simplify that any further? And you're like, oh, I've seen a rule sec squared minus 1. you go here in your rules, tan squared plus 1 equals sec squared. So if you transfer that 1 over, tan squared is sec squared, take 1. So x squared equals tan squared y. Therefore, you'd have x equals plus or minus tan y. Because we're taking the square root of both sides, we know we can go plus or minus. Have we finished? It tells me that when x is positive, y is between negative pi on 2 and 0. So we've got two different tan graphs. Consider. This is my regular tan graph. When x is between 0, this is negative pi on 2. When x is bigger than 0, y is between negative pi on 2. That's not working. But what happens if we did, so this is y equals, x equals tan y, and x equals negative tan y. Oh, I kind of did it the wrong way around. Probably that's not the best explanation, is it? I'm trying to explain it in what would be the simplest way. But we've kind of explained it a bit funky, haven't I? Maybe let's not worry about that bit. X is going to be equal to negative tan y. One of the ways I look at it is, go back to your unit circle. When x is positive this way, and y is between negative pi on 2 and 0, so it's down here, tan is positive here, isn't it? And tan is negative here. So this is all my x being positive. So for x bigger than 0. So if x is bigger than 0 and y is between negative pi on 2 and 0, tan has to be negative. You get a mark for that. You get a mark for the plus or minus. I think you get a mark somewhere else over here. There's a few marks kicking around. I've probably missed one. So tricky straight through differential equation to solve. Simplifies down really quite nicely, and it's negative tan.